let's add our parameters to dispersion. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous episode, I did do some brainstorming about the different things that Olama suggested to me. And honestly, most of them are good suggestions. So in this video, we will implement part of that. And in the next videos, we'll continue implementing the rest. One of the things that we need is a new Java class that is enumeration, and that is dispersion type. And as Olaba suggested, we have solution, we have suspension, we have emulsion, colloid. By the way, if I pronounce some of these wrong, I apologize. English is not my native language. Aerosol, foam, gel, paste, solid dispersion that I abbreviated to solid, and then something that is really interesting, nano emulsion. Apparently, it's a new form of emulsion. Then I will add two more myself as custom and none. Basically, none is when we are dealing with empty, or let's add the empty here. Who cares? So none is when we didn't implement anything and we just want something there. Custom is just there so that if anyone wants to do anything sci-fi in his mod, he can achieve that without being limited to the normal physical definitions. Now, each one of these has some definition in physics. I will add one of these as the Java doc, and between the episodes, I will come back and finish them. So solution is homogeneous mixture where the solution is uniformly dispersed in the solvent. Both are usually liquids. The solute is typically dissolved in the solvent. Example is salt, water. In this case, one of them is solid. So usually both of them are not liquid. Anyway, that's one example. And honestly, I may want to tweak these a little bit later. These suggestions are the things that was given to me using the Qwen, and Qwen is a model that was developed for coding and not chatting. So I may go back and ask about them from ChatGPT and add them here as documentations because some of them are interesting. For example, the paste is this thick semi-solid mixture that is often viscous, consists of fine particles suspended in a liquid medium. Example, toothpaste and peanut butter. I may add them because honestly they are fun to have there. And honestly, I'm a very lazy guy. I don't want to remember all these physical terms and their meanings, and later I can use them. After having our dispersion type, I want my dispersion. Now, here's the thing that I need to think about. We have dispersion and we have dispersion variant. One of these has the type. For example, the dispersion. It can be a solution or a suspension, but then we have two more words that we need to implement somewhere in the code, and that is terms solvent and solute. Now, solvent and solute are mixture components, and because of that, I need the component class, so I will come back to this dispersion later. However, for time being, I will add on top of this. So I want the dispersion type, and we call it dispersion type. Then we have the double as viscosity, a double for density, a double for stability, and then a double for heat. However, I get this heat and I will move it before the rest. One more thing, I have this heat API that is totally a copy of what Turtivorti has, with a minor tweaks here and there. It has heat units. This is the heat unit. As you see, we have heat unit, for example, .Kelvin, and we can use that. However, to use it, I need to make sure that I have heat API as a dependency for this guy. We added gas, I will add heat. Yes, I need to sync my Gradle, and I will come back. Now I can use the heat unit inside dispersion right after the heat, because honestly, when you are defining the heat, you need to define what type of unit you are using. So this is heat unit. Now I'm thinking about adding more method calls here. For example, I can say it's a public static that returns a dispersion, and we call it of. And all I'm doing here, I will just add the ID. So we return a new dispersion with the ID. However, for the type, we go with dispersion type dot solution. That's the most relevant thing. And then for heat unit, we will go with heat unit dot Celsius. And for the value, actually, we go with heat constants dot Celsius dot room temperature. Then after that, we have the viscosity. Let's go with 0.0. For density, it's 0.0. For stability, I will go with 1.0, means it's totally stable. And that's it. So this will be a solution at the room temperature that doesn't have any viscosity or density, and it's totally stable. Then I can have another one, for example, public static, that returns a dispersion of. From this one, I will just use the ID and dispersion type. Copy this guy, paste it, and this time I will go with the dispersion type. The next one of public static dispersion of, and here I will keep the heat and not the rest. So we say return new dispersion of ID with dispersion type with heat and heat unit. Then we go with 0.0, 0.0, 1.0. Now we can go crazy with this. I mean, even here I can drop the dispersion type and go with the solution that has heat and heat units. However, I leave it. Actually, let's do that one as the last one. So no dispersion type. Here we go with dispersion type dot solution. And as I said, you can go as heavy as you want on these overloads for the of. For example, you can have the ID and the stability, then the ID dispersion type and the stability, then this plus heat plus stability. But then you can't have any one of these as single ones because the last parameter is always a double. Honestly, I think these two, if you are going to use them, then the original constructor would be more than enough. So again, as I said, it's up to you. If you want to, you can use all of that. It's really not that hard, actually. Let's implement them. So here we want this double stability at the end of each one of them. So you start from here, 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 and here. Copy the stability, paste it wherever you see 1.0. And just like that, you got your last 4 overrides within a minute. And honestly, these are all that I want in here for time being. I can add another thing on top, and that is adding 2 lists. However, for that, I need another class for the mixture component. I will come back in the next video and I will add the mixture component and we will take a look at that. Have fun, everyone. Bye.